of 2, and then I outside the radical.
Like that?
Yes.
Got it. Okay, so what's the problem here? Do you know why it isn't simplified?
Well, there's a square root on the bottom.
Yeah, that's exactly the reason. And more than that, I can't be on the bottom either, because I counts as a square root number.
Oh, yeah.
Okay, so how do we get out of this problem?
Multiply by 1. I don't know.
Well, yeah, I mean, we multiply by 1, but what exactly should we multiply by?
The square root of 2i.
So that's not going to cut it. What we need is called the complex conjugate. It is, I know, it's exactly what the denominator is, except in between is the opposite sign.
Oh, right, okay.
Okay, and the reason why we want to do that is because we want the minus root 2i and the plus root 2i to cancel out when we do FOIL. Okay, so we are multiplying by 1. We just have to do the same thing on the top and bottom.
Yeah, okay.
Complex conjugate. Okay, so in my numerator, just do FOIL. Okay, so I got 1/2 plus root 3i plus root 2 over 2i plus root 6i squared. Are you with me on that one?
Hang on, I'm scrolling.
Oh, yeah. Scroll down a little bit.
Okay, let's see. Okay. First, wait. How did we get? Yeah, how did we get the square root of 3i?
Okay, so that was the inside. It's this thing times 1.
Oh, okay. Okay, yeah.
Yeah, okay. So now let's look at the denominator. So this is that difference of two squares pattern where the inside and the outside cancel each other.
Yeah.
Okay. So, if you don't see it, then you use FOIL and then you just cross them out. If you do see it, then you can save yourself a step and just do, like the a squared minus b squared.
Mm-hmm.
Do you know what I'm talking about?
I think so.
Yeah. I mean, you don't have to show you.
I do remember that it does that, like, because I've done it before. But I generally just write it out anyways.
No problem. Then let's just write it out. So okay. I've got 1 minus root 2i plus root 2i. Right, so those are the ones that are going to cancel. And then I'm going to have minus 2i squared, because root 2 times root 2 is 2.
Yeah.
Okay. All right, and now we simplify it. So looking at the numerator, there are no like terms. I'm going to have to scroll down some. There are no like terms because the radicals have different things inside.
Mm-hmm.
Okay, so what I'm going to do is just write it in like what we consider to be standard form for complex numbers, and that's to put all of the real numbers first. So the 1/2 and then minus root 6. Okay, that's the real number part. And then I'm going to put the imaginary part. So that'll be root 3 plus root 2 over 2i. Actually, if I'm going to be like mathy about it, the I should go in the back. Is your teacher like picky about that kind of stuff?
No, I mean, he'll let us know when, like, he'll be like, oh, well, normally people won't accept it this way, but I'm letting you know. But on the test, it'll be, you'll have to have it the right way, but I will accept this, like, in the homework.
Gotcha. Okay, so the idea is that, a complex number is in the form a plus bi.
Mm-hmm.
So just make your answer look like a plus bi. That's the bottom line.
Okay.
Okay. So the denominator, these guys go away, and I have 1 and then plus 2. So my denominator is just 3.
Okay.
All right, and that should do it. I mean, if your teacher doesn't go nuts with simplifying, then this would be good enough.
Okay.
Okay? All right.
Mm-hmm.
So what's next?